In this video we're going to go through a not very commonly asked question in recent years on simplex method in game theory for D2 Edexcel. We're commonly asked to set up as a linear programming problem, but not that often to go on and actually put it into a simplex tableau and begin to solve. Even in this case we don't actually get to the end because it takes quite a few iterations it would do to actually solve the thing. The other difference to many questions here is it says write them as equalities. That then kind of leads into part C where we're putting it into a simplex tableau. Anyway, let's get on with it. To set something up as a linear programming problem, we need three things. We need first of all our decision variables. Okay, we need our objective function. And we need our constraints. In other words, I don't think I need that much space for my objective function. Okay, constraints. In other words, subject to what constraints are we trying to maximize or minimize our objective function. So let's start off with the decision variables. It says from A's point of view, and A needs to decide the proportion or probability that they play each of the three options. So we can say let P1 be probability A plays row 1. Let P2 be probability A plays row 2. And P3 be probability A plays row 3. Okay, so that's the probability bit. We also need to define the V. Now in this case, we often in these questions with game theory, we have negatives and we have to add on the lowest number, which makes them all positive and non-zero. But here they're all positive anyway. So I'm just going to let V be equal to the value of the game to A. Right, now the objective function is maximize P equals B. Now that feels a bit strange first of all, but it might be worth referring to back to our actual rugby post. If we had only two options for A and three constraints there, we might have a rugby post arrangement, say, of something like this. Okay, and the feasible region being anything below these lines. So this is a feasible region. And the thing we're trying to maximize is our P equals to V here, is that line. And we're trying to make that up higher. So referring to our actual the way we solve the two variable problem may help us in both ways. One, to remember how this kind of rugby post thing works, but also might help us remember how to set up our objective function, whatever, when we're talking about setting up game theory as a linear programming problem. We need to do the constraints now. Obviously, if A plays 1, then we've got 5P1, or let me just write it like this, V is less than or equal to, and again the less than or equal to can easily be seen by the fact that we're below the lines when we're doing this diagram in game theory. So if you're ever wondering, because it's a bit strange sometimes, you can get confused as to which the direction of the inequality is, because obviously ultimately we're regarding it as equal. So that might help us remember that it's got to be below the constraints there. So therefore hopefully that helps us remember the direction of the inequality. V is less than or equal to V is less than or equal to 5p1 plus 3p2 plus 6p3. Right, but before you're thinking I'm getting this wrong, it wants equalities here. That means slack variables. So let's set it up like this. Let's get rid of the, let's change the direction so it's this. Minus, 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 less than or equal to 0. Still not what we want really, because we want a slack variable. That just changes an inequality into an equation. So let's call the slack variable r, say, plus r equals to 0. R because the inequality is in that direction. So it's less than on the left-hand side. So that's the r is the amount less than it actually is. And we can do that for all of these. If a plays 2, then we get v minus 7p1 minus 8p2 minus 4p3 plus s is equal to 0. And then if a plays 3, we've got v minus 2p1 minus 4p2 minus 9p3 plus t, say, equals 0. Okay, we're not done yet, but that's the main one related to the numbers here. Those are the 3 that we've got. Now, we've also got one relating to these values, which actually add up to 1. Now in setting up you can say it's equal to 1, I think, but again, because we're setting up as a tableau, I'm going to introduce a slack variable, so it's equal to 1. And say, so in other words, we kind of replace it with this much looser statement, less than or equal to 1, so that we can set it up as a linear programming problem, and then obviously changing that inequality to a equality with a slack variable u is equal to 1. Right, now, don't forget the other important stuff, non-negativity. P1, P2, P3 are greater than or equal to 0. Now, because we're setting up as a linear programming problem, we probably ought to also specify that our slack variables, because we're not using inequalities, we better specify also that our slack variables are greater than or equal to 0 as part of our setting up, so that it's all consistent and clear. Right, okay, so that's the first question. Now part B says, explain why it's necessary to use Simplex algorithm to solve this game theory problem. And the reason is because we've got 3 options for A. A has 3 choices, or A has 3 choices, rows. Now, of course, often that's so rows sometimes can be reduced by dominance. So we better say which cannot be reduced by dominance. Okay, so I'm going to, now we're on part C. It's basically, we're going to put these numbers into our simplex tableau, and also the P equals to V into our Simplex Tableau. So this is how the Tableau is set up. Don't forget to have the V here. Okay, we've got RSTU as our select variables, P1, P2, P3, RSTU as our variables. Okay, and value and row operator or theta value. Right, so let's just go through this. Let's put this one in. That's 1 minus 5P1 minus 3P2 minus 6P3 plus R and all those are 0 equals to 0. Okay, next one, V, so that's a 1 minus 7P1 minus 8P2 minus 4P3 plus S equals 0. Okay, and then 1 minus 2P1 minus 4P2 minus 9P3 0, 0 plus T 0, 0. And then the P1 doesn't have this one here doesn't have a V in it. That's 0, 1, 1, 1, 0, 0, 0. It's got the U as its slack variable, and the value this time is 1. And then finally, we've got our P equals to V. That's the same as P minus V equals to 0, obviously. So we've got P minus 1 and then a whole series of zeros. Okay, so that's part C done. Part D is to go on, and if we go back to the question, it says perform 2 complete iterations. It's not going to solve it. I'm looking at the one from the Heinemann textbook here, I've got it in my hand, and it seems to go through 1, 2, 3, 4, 5, 6, 7 iterations, 6 or 7 iterations to get to the solution. There's absolutely no way you'll be asked to do that. So it just would take too long, and we need to test the whole of the syllabus, not just one thing. Whether you can do if you're ace at the Simplex method, it's no good if we haven't tested the rest of the stuff for you. So you wouldn't be asked to do something so repetitive. So here we're not getting to the end of the problem. It's just asked to perform 2 iterations. We get the idea that if we were to carry on, we would get a solution. Okay, so we're going to do 2 iterations. Let's do the first one. Obviously, we look for the most negative pivot column. Well, there's only one negative here. Now, working out theta values, they all give the same, infinity, in fact. So that's a bit, sorry, they all give 0, and this one gives infinity. So these all give 0. So it's arbitrary which one we choose. Theta value is basically the 0 divided by 1. It's the value divided by whatever column we're considering. It all gives 0. So arbitrarily, we choose the 1. Okay. Now, in this case, that means because that's our pivot, we swap out the thing in our pivot column in the row there, VSTU. Right, now for row operators, because we've got a 1 there already, remember we would need to reduce this to 1, but in this case it doesn't mean doing anything. So we've got R1, so it's just a straight copy of, and it will always be like this. So always arbitrarily choose the first row, even though obviously the second and third row would be, no reason to know which one will be more efficient, but we just arbitrarily choose the first one. So that's that. Now we need to reduce all of these to 0 here. We need to get to 0 on all of these in this column here. We need to get everything to 0. That's how the simplex works. Need to reduce all of these to 0, so I'll keep referring back to that. What I'm going to do is I'm going to highlight my pivot row. This is my pivot row here, and so that I'm always checking the right numbers, because if you're anything like me, you get mixed up with the numbers that you're considering. So you might want to do this in light pencil in the exam, or find some way that you know that you're actually doing the correct, taking the correct numbers away or adding to the correct things. So in order to, let's consider the row 2 first, the old row 2, right? And let's go back to, right, okay, so we want to get from 1, we want to change this 1 to a 0 by means of this pivot row here. So that's basically just R2 take away R1. Now don't forget, R1 is the new R1, that's a pivot. Some people say pivot row, which is okay. The new R1, whereas R2 is the old R2 up here. Okay, so let's just do that for each of the numbers. Okay, -7 take away -5. That equals to -2. Okay, -8 take away -3. That equals to -5. -4 take away -6, that gives me +2. 0 take away 1, that gives me -1. 1 take away 0 gives me 1. 0 take away 0 gives me 0. 0 take away 0 gives me 0. 0 take away 0 gives me 0. Okay, do be careful with these. Sometimes I tend to have a tendency to just write a load of zeros at the end, because so many of them are, but then they end up as 1, some of them, which reminds me, let's make sure I've got my 0 there. Okay, so let's now consider the next row. Here. Now I want to, I say we wanted to reduce it to 0 here, and they're both 1s in our original R3, and our pivot row is 1. So we're just going to take one lot of the pivot row away. So that's R3 take away R1, which is our pivot row. So it's the same thing. So we're going to do -2 take away -5, that gives me 3. Okay, so -4 take away -3, that's equal to -1. -9 take away -6 is -3. 0 take away 1 is -1. 0 take away 0 is 0. 1 take away 0 is 1. 0 take away 0 is 0, and 0 take away 0 is 0. Okay, let's move on to the next row. Okay, and let's just highlight this one and say, if you can find some way of kind of making sure that you're not looking at the wrong row, maybe you're better at this than me, but I always find I'm looking at the wrong rows or whatever, so just take lots of care. Okay, so now, well, actually, at least in this case, it's quite easy because we've already got this as 0, so there's no change to R4. We don't have to use the pivot at all, the pivot row at all. So that's just equal to R4. So that's 0, 1, 1, 1, 0, 0, 0, 1, 1. Okay, so that's that one considered. And then our profit row, we did have -1, we've got to have 0, so in order to, we've got a 1 here, so we're going to add on the pivot row, so that means we've got, that equals to R5 plus R1. So -1 plus 1 is equal to 0. 0 plus minus 5 is minus 5. And you might find these come out quickly now because we've got a load of zeros here. So it's just the same numbers as these ones here. So that's minus 5, minus 3, minus 6. And it will always be like this for this on the first time you're doing your profit row, because you've got P minus V, you've only got the minus 1 there. So it's only the first number it changes. Okay, so that's the first iteration. One more to go. Okay, let's just get rid of that. And let's get rid of that now. Okay, now this is the most negative, so that's negative 6 here. Okay, we've got negative 6. Now, obviously we can't have a negative pivot of negative 6 or minus 6 or minus 3. If we're looking at our theta values, we've got 0 divided by 2, which is 0, or we've got 1 divided by 1, which is 1. So the least of them is 1. So this is our pivot row. So let's put that as our pivot. That's our pivot row. Well, that's our pivot now. So let's deal with the pivots first under basic variables. Right, so the basic variables, V. Now this time, S is gone because that's in our pivot column. Our pivot column is P3, so S gets replaced with P3, T and U. And then we need to reduce this number here, the pivot, to 1. So that will be equal to R2 divided by 2. Okay, so let's just do that. That gives me 0, minus 1, minus 2.5, and 1, minus 0.5, 0.5, 0, 0, and 0. Okay, so now let's highlight that as my pivot row. Okay, so that's my pivot row, and I want to reduce my rows to all the numbers here accordingly, so that remember this was my pivot, so I want to get 0. Let's change back to blue. I want to get zeros in all of my pivot columns apart from the 1 there. So I want to get zeros there in each of these. Okay, so let's deal with the row 1 first. So remember that's the old row 1 here. We did have a minus 6 and we've got a 1 here. Obviously we always have a 1, so we want to add on 6 lots of let's change back to blue again. Try and be consistent with the colouring. So that's R. Oh, I've lost my train now. So that's R1, which is the old R1, plus 6 lot of R2, which is the pivot row. So some people just write pivot row. Some people write R2. I put R2 and a star on it, just to remind myself that it's a pivot, not as opposed to here, which is the old R2. But okay, that's fine. So now we want to do that for all of these numbers. So that's 1 plus 6 times 0, so that's 1. Minus 5 plus 6 times minus 1, so it's minus 11. Minus 3 plus 6 times minus 2.5. Now 6 times minus 2.5 is minus 15, so it's minus 3, so it's minus 18. We've already dealt with this one, which is 0. Then we've got 1 plus 6 times minus 0.5, so that equals to minus 2. And we've got 0 plus 6 times 0.5, so that's 3. Then we've got 0 plus 6 times 0, so that's 0. 0 plus 6 times 0, so that's 0. 0 plus 6 times 0, so that's 0. Okay, so that's the first row done. So let's move on to row 3. we need to reduce that 0. There was a minus 3 there, so we need to add on 3 lots. Because we've got minus 3, we need to add on 3 lots of the pivot row. So that's R3 plus 3 times the pivot row R2. Okay, and let's just go through the process here, being careful. 0, add on 3 times 0, which is 0. 3, add on 3 times minus 1, which is also 0. Minus 1, add on 3 times minus 2.5. Now that's minus 7.5 minus 1, it's minus 8.5. Then we've done the 0 as well in our pivot column. Minus 1, add on 3 times minus 0.5. So that's minus 1.5, so that's minus 2.5. 0, add on 3 times 0.5, that's 1.5. 1, add on 3 times 0, so that's 1. 0, add on 3 times 0, so that's 0. 0, add on 3 times 0, that's 0. Okay, so that's that row done. So now let us consider the 4th row. Okay, now we did have the 1 there, and we now need to reduce it to 0 by means of the pivot row. So that's just taking away the pivot row. So it's R4, take away R2, the pivot row. Now, okay, so let's just do this then. We've got 0. Let's change back to blue. I am on blue. Okay, fine. 0, take away 0, which is 0. 1, take away 0, which is 1. Oh no, that's a mistake. 1, take away minus 1, which is 2. Nearly got there. So, without making a mistake, but there we go, it's 2, because 1, take away, even though I'd highlighted it there, I looked at the wrong number. I looked at the 0, so just be careful. So 1, take away minus 1 is 2. So the 1, take away minus 2.5, that's 3.5. It's almost like when you make a mistake, you get back on track and you just get that much more careful again. So it's 1, take away 1, that's equal to 0. Obviously, we'd already done that. 0, take away minus 0.5, so that's equal to 0.5. 0, take away 0.5, so that's minus 0.5. 0, take away 0, so that's 0. And 1, take away 0, so that's equal to 1, and 1 take away 0, 1 take away 0, which is 0. Okay, finally, the profit row. Right, it was minus 6 here. We want to reduce it to 0. So for the profit row R5, we need to add on 6 times the pivot row. Okay, so let's highlight that again so that I don't just take care, otherwise I might start looking at the wrong number. Okay, so we've got 0, good. 0, take plus 6 times 0, which is 0, minus 5, plus 6 times minus 1, which is minus 11. So it's minus 5 plus 6 times minus 1 is minus 11. Minus 3 plus 6 times minus 2.5, that's minus 18. And the minus 6, 1 reduced to 0, we've already done. 1 plus 6 times minus 0.5, 1 plus 6 times minus 0.5, which is equal to 1 take away 3, which is minus 2. Then we've got 0 plus 6 times 0.5, so that's 3. 0 plus 6 times 0, which is 0. 0 plus 6 times 0, which is 0. And 0 plus 6 times 0, which is 0. And I've just noticed on the row above, going back to that, just crazy really. The row operator for this one was R, take away R 0, so that should have been a 1. I did, and funny enough, I was talking about how easy it is to look through those zeros and ones and take away the wrong one. I also started going a bit strangely here, but we've got there in the end. Hopefully you've got the idea. And sorry, I made a few little kind of blunders there, but we got there in the end, and I hope that that video is useful. This hasn't been up since 2007. This is in summer 2016, so who knows whether this is a likely thing or not. I certainly wouldn't want to leave it to chance, so I would want to be looking at this. Hopefully you found this helpful. Bye.